Hi, so everyone. It is day 13 of studying Martin every day, and it's another beautiful day. Today, I'm going to start a new section in my course, and I don't know what it is all about, but like, let's check it together. So, I was studying rational functions, okay? So, now I'm about to start this section, section 15. Like, let me go back one more time. Okay, symbol is that. Okay, so this section is just like inverse variations, decimal equations, fractional equations. Oh, to be honest, this look is a little bit complicated. I don't know. I don't know. I never heard something which is called direct variation, inverse variation. I don't know what it is. Never heard of it. I didn't learn that in Algebra 1. So yeah, decimal equations. That sound is familiar, although I didn't deal with it. But yeah, oh my gosh, oh my gosh. So yeah, let's go back to studying the chemical compounds. Okay, no music. There's no music. Play the music. Not this one. Let me find another one today. Memories. This one looks good, I guess, or this one. Yeah, this one looks fire. But I don't know if this is like if this have a copyrighted. If this like music that I listen to are copyrighted, I don't know that. If they are, I'm cooked. I swear to God, they're gonna take my whole videos down. It is so scary. But how can I know though? Maybe I'm about to do some research about this later. So yeah, I'm about to watch this lesson, but not here. I'm gonna watch it from my computer, my laptop basically. So yeah. So let's stop yapping and let's start studying. Oh, all I wanna listen to this lesson is this first one. So let me make it. Oh, there is no battery in it. It is died. Don't even have water. And how many sections left? 16, 17. Oh, 17 looks like 2 hours, man. This one also 2 hours. Exponential and logarithmic functions. I will be cooked. I will be cooked. And what's next though? If I finish like algebra 2, what is next? What should I study? Should I go to calculus or like linear algebra or what's the other thing? Um, the math topic that's all about just like shapes and blah blah blah. What was it? Oh my gosh. Call it a name. Yeah, geometry. Or should I go to geometry? Ario.
which puts you at the end.
In this video, we're going to talk about direct variation. What is that? Direct variation is the relationship between two variables, in this case, x and y. Here's a graph. X is the independent variable, y is the dependent variable. When y varies independent variable, y is the dependent variable. When y varies directly with x, what we're going to have is a linear relationship. The equation that corresponds to it is y is equal to kx. As x increases, y will increase at a proportional rate. K is known as the constant of variation. If you want to calculate k in this situation, it's simply y divided by x. So feel free to write this down as we're going to be using this information. In this video, we're going to talk about direct variation. What is that? Direct variation is the relationship between two variables, in this case, x and y. Here's a graph. X is the independent variable, y is the dependent variable. Here's a graph. Direct variation is the relationship between two variables, in this case, x and y. Direct variation is the relationship between two variables, in this case, x and y. Here's a graph. X is the independent variable, y is the dependent variable. When y varies directly with x, what we're going to have is a linear relationship. The equation that corresponds to it is y is equal to kx. As x increases, y will increase at a proportional rate. K is known as the constant of variation. If you want to calculate K in this situation, it's simply y divided by x. So feel free to write this down as we're going to be using this information to solve this problem. So let's start with number 1. Y varies directly with x. If y equals 8 when x is 2, what is y when x is 7? So the first thing we want to do, step 1, is to calculate k, the constant of variation. Keep in mind k is y divided by x. Y is 8, x is 2. 8 divided by 2 is 4. So k is 4. That's the first thing that we want to do. The second thing that we need to do is write the equation. So the equation is y is equal to kx. What we're going to do is we're going to plug in k into that equation. So the equation is y is equal to 4x. And now that we have the equation, we could answer the second part of the question. What is y when x is 7? So now we need to plug in x. We're going to replace x with 7. So this is going to be 4 times 7 is equal to 28. So that's the answer for part A. That is the value of y when x is 7. Now go ahead and try part B.
So let's try part B maybe. Now, if y is equal to 9 when x is equal to -4, what is y when x is equal to 11? I literally forgot it. Okay, if y is equal to 9, y equals to 9. When x equal -4, x -4, what is y when x is equal to 11? Y when x is equal to 11. Okay, so first of all, we need to find the constant k. Let's find k. Okay, so in this case, so we need to find k. So k, so all we need to say is this: k, so y divided by x. So at this moment, k is equal to y is 9 divided by -4. X, this is just like 9. Let me use calculator. Okay, it's 9 divided by 4, 2.25, but it is minus. Oh, but I literally forgot it. 2.25. 2.25 minus. I don't want to forget it. So if y, okay, so let's answer. Let's find y. Let's make the equation. Let's make the equation. So the equation will be something like this. Now you need to pick 7. So the equation will be something like this: y is equal to minus, maybe you need to say this, y is equal to k times x, which leads to us this y equal to minus 2 times 5 times x. So, and then at the end, let's find y. Let's find y. So let's find y. So y is equal to minus 2 to 5 times 11, which is equal to, get my calculator, 2 times 2, 5 times 11, 24.75. 24.75 but negative. So this is what I got. Let me see.
If y equal 9 when x is negative 4, what is y when x is 11? So step 1, we're going to calculate k. Step 2, we're going to write the equation. And then step 3, we're going to calculate the value of y. So k is y over x for direct variation. Y is 9, x is negative 4. So we can write k as negative 9 over 4.
So okay. So if you cannot divide in a normal way without like getting any decimal value, then you can use the fraction. You don't need to use you don't need to change it, or you don't need to convert this fraction into decimal. So you can just use the decimal. I literally forget that. But like, we are talking about real values though. Right? We need to know how the y value rise with the x value, right? So yeah, it is what it is.
So now let's write the equation. Y is equal to kx. So the equation is y is equal to negative 9 over 4 times x. Now the last step is to plug in the value of x to get y. So we want to calculate the value of y when x is 11. Negative 9 times 11 is negative 99. Now we can't really reduce that fraction, so I'm going to leave the answer like this. Y is negative 99 over 4. If you want the decimal equivalent of that, this is negative 24.75. So that's how you can solve direct variation problems. By the way, for those of you who want more problems on direct variation, including inverse variation and even joint variation, check out the links in the description section of this video. I'm going to be posting some other content.
Each function schablon determine whether y rise directly with x.
There that you might find interesting. Now let's work on this problem. For each function shown below, determine whether y varies directly with x. So we're given the data in a table. How can we find the answer? How can we determine if y varies directly with x? The key is to calculate the constant of variation, k. Keyword constant. For every pair of x and y values, k has to be the same. So remember, k is y divided by x. So if we take the y value and divide it by the x value, what do we get? 4 divided by 2 will give us k. So I'm just going to add another column for k. So 4 divided by 2, we know it's 2. 10 divided by 5 is 2. 14 divided by 7 is 2. So notice that k is constant, it doesn't change. So because it's constant, we can say yes. For the first table, y varies directly with x because we have a constant of variation. Now what about the second table associated with b?
Don't even check this one.
Let's calculate k
There's not.
for each pair of x and y values. 3 divided by 1 gives.
So we're gonna say if k is not constant value, then that means like this is not a direct variation, and y does not varies with x. That's how it is. So yeah.
Of x, constant of variation. No, varies directly with x because we have a constant of variation.
That is what it is.
Now what about the second table associated with b?
This is not, I know it.
Let's calculate k for each pair of x and y values. 3 divided by 1 gives us 3. 5 divided by 3, that's not 3, that's like.
Could I also watch this
1.67.
lesson?
Repeating or
Wow, I like
1.63.
this guy, dude. Maybe I'm about to
12
watch this.
divided by 7, that's not going to be 3 either. 12 divided by 7 is approximately 1.71. So looking at the values of k, they're not the same. So we could say y does not vary directly with x. Now let's move on to part C. Let's calculate k. 12 divided by 4 is 3. 21 divided by 7 is 3. Negative 27 divided by negative 9, that's also 3. So for this table, k is constant, which means yes, y varies directly with x. So that's how you could determine whether y varies directly with x or not. It's by calculating, let me say that again. It's by calculating the constant of variation. If it's the same for each pair of x and y values, then the answer is yes, y varies directly with x. So for this table, k is constant, which means yes, y varies directly with x. So that's how you could determine whether y directly with x, which means yes, y varies directly with x. So that's how you could determine whether y varies directly with x or not. It's by calculating, let me say that again. It's by calculating the constant of variation. If it's the same for each pair of x and y values, then the answer is yes, y varies directly. whether y varies directly with x. So that's how you could determine y varies directly with x. Constant 7 divided by -9. That's also 3. So for this table, k is constant, which means yes, y varies directly with x. So that's how you could determine whether y varies directly with x or not. It's by calculating, let me say that again. It's by calculating the constant of variation. If it's the same for each pair of x and y values, then the answer is yes, y varies directly with x. Number 3, the distance
It's going to be my first break, and I will go to my second session after this 10 minutes ends. So before that, I'm just gonna go. Okay, I'm gonna go out and maybe get something to eat. I don't know. I'm just like gonna chill outside. But yeah, this is fun. But I thought like this is little bit complicated, but it looks it is not. I know it got like some word problems in it, but I wasn't expecting like it will be so simple to calculate. Right? Like calculating for k is so simple. You're just gonna divide y by x, simple as that. And yes, you can, it is easy to know also if y is directly varies with x. Is so simple because like you already got the constant, right? So yeah, man, I don't know if like it will get serious at the end, but like so far everything seems simple and easy.
distance that Karen walks varies directly with the amount of time she spends walking. If Karen can walk 2 miles, the distance that Karen walks varies directly with the amount of time she spends walking. If Karen can walk 2 miles in 25 minutes, how many miles can she walk in 1 hour?
So maybe let me try this. Let me out. So in this case, we need to find if Karen can walk 2 miles in 25 minutes, how many miles can she walk in next is, and how many can she walk in an hour? Select the timestamp. Okay. So okay, how many miles? So it is time and what? And mile. So basically we need to get the mile. Right? The mile. So time to the need to find the miles. Okay. So what will the K be? So the K is what? Okay. So to find K, we used to use this formula, y divided by x. So what is my x and what is my y in this case? So we are looking for the miles, right? So that will be the y, okay, and the x will be the time. So if she can walk 2 miles in 25 minutes, so if she can walk 2 miles, which is just like at this point, mile would be the y, and this one with the x. In my opinion, this is how I'm gonna approach the problem. So k is equal to then k is equal to y, which is my miles, okay, 2 divided by 25. Okay, wait up. If Karen can walk 2 miles in 25 minutes, so every 25 minutes she can walk 2 miles. I cannot do this, to be honest, because it will go in a fraction. But yes, it is what it is. Okay. Basically, this is the K. Okay. So I got the K. It is 2 divided by 25. So let me find the Y. I got the K, which is 225. How many miles can she walk in 1 hour? Which is like 1. It doesn't change. Yes, I'm doing something wrong. Karen can walk 2 miles in 25 minutes. Which one is the X and which one is the Y? That's what I want to know. So how many miles can she walk in 1 hour? So like the second part of the equation, it is how many miles. So at that point we need to find the Y, right? So Y, which is the mile, will be that. Okay, I think I'm doing wrong here. Can I simplify this? Nope. Looks like I cannot divide this by 2. Can I divide 25 by 2? Nope. It will be 13.5, right? Something like that. So this, maybe I need to change this into decimal. No idea. So 25, 2, just add 0. Add another 0 into here. Damn. Gives me 25. This is too much. Hell nah. What will it be? It will be what? 4? No, 8, I guess. Because like 4 times 25 equals to 100. So another 4 will be 8 will be, I think, 8. So yeah. Good. Nope. I already filed it, I guess. I don't know if I was close or not, but
So
that's
go
how
ahead and
that's
pause the
how I
video
will do.
and try this problem. It's another direct variation problem. What we know is that the number of miles that she walks, it varies directly with the time that she spends walking. So that is the minutes. So let's say Y corresponds to the mileage and X correspond to the time in minutes.
Yes, I was close, man. What am I doing wrong then? Am I doing wrong something over here? Wait up. What do I need to do by this with this? It's like this won't change. 2 times 1 will just be like 2 divided by 25. So is the Y then like this? We need something which is meaningful, right? We need how many miles can she walk? I think where did I get the 25? Okay, it's 25 minutes, right? And I don't need to change it into milliseconds. I'm sure. So do I need to change this into decimal? Right up. 0.8, right? 0.08. Hey, how can I change 0.08 to miles then? Oh my gosh, I'm cooked. But yeah, I was getting close, I believe. I don't know what I'm
So
doing
we can
wrong now.
calculate k.
But yeah, I will
K
see.
is going to be y over x.
Okay.
So 2 miles for every 25 minutes. So k is going to be 2 over 25. So that's step 1, finding the value of k. Step
Okay.
2 is writing the equation. So y is equal to kx. Let's substitute k with what it is, 2 over 25. So this is the equation.
Okay, I got the equation too.
Now, x has to be in minutes. It can't be in hours.
Okay.
How many miles can she walk in 1 hour? We need to convert
This is going to be 60 minutes. Wow,
hours to minutes.
I just forgot that.
Fortunately, we know that 1 hour is equal to 60 minutes. So all we need to do is plug in 60 into this equation, and that is going to give us the mileage that she can
120.
walk in 1 hour. So it's y is equal to 2 over 25 times 60. Now 60, we could break that into smaller numbers. 60 is 5 times 12. 25 is 5 times 5. So what we can do is cancel a 5. 2 times 12 is 24. So the answer is 24 over 5 as an improper fraction, which is 4.8.
So she can walk 4.8 miles in 1 hour. So yeah, it makes sense. Yeah, let me count right here. Get this. And then let me take the quiz maybe. Where is the quiz? If 3k equals 15 and kx equals 75, find x. Why is this a little bit different? Direct variation. So wait up. What's this table formula though? How is she doing things? So k equals to 5. Okay. So 75 is proportional uh, to k times x. So k is 5. So 5x is equal to 75. Then I guess what is 2? We'll both cancel. I don't know. 75 divided by 5 is equal to 15. So x is equal to 15. So the answer will be the C. Let's see this one. Which equation is not an example of a direct variation? Which equation is not an example of a direct variation? Okay, so which equation is not an example? Will it be the A? Okay, it is clear. I think it will be the D. I think. So if we attach weights to a hanging spring, okay. First, I don't know what is hanging spring is. Hanging spring is a mechanical pipe support that carries vertical loads while allowing this. Yeah, I think I can know it. So attach weights to a hanging spring. Okay, yeah, it will stretch. Okay, the amount of stretch varies directly with the amount of hanging weight. If a weight of 20 will stretch the spring a distance of 4, what distance will a weight of 50 stretch it? Let W be weight and D be distance, and use the equation W equal to KD. I would like to write the whole thing down, but this is an image. You cannot do it. Wanna have it? How can I do it? I think I'm about to save this. Can I even save it? Okay, save image. Okay, and I'm gonna put it in here. Oh, what is wrong? So if we attach weights, so we're gonna say, okay, so if a weight of 20 will stretch the spring a distance of 4, what distance will a weight of 50 stretch it. So a weight of 50 will stretch the spring a distance of 10. So we're gonna say weight of 50 will is stretch the spring a weight of 10. Let's see the answer. We're gonna choose the B. So yes, I'm right then. So yes, I think I can understood the thing, but I also wanna watch this lesson. I like this dude.
Direct linear variation. Let's unpack each of these three words so that we know what we're talking about and why it applies. Variation. Variation, we can start at the end. Just means when something changes, right? So this is about changing quantities. These are quantities that don't stay the same. Things like time or distance or temperature. They change, they vary, but they vary in a particular way. Right at the front here, direct. This word's a bit weird because I don't see any reason why it's called direct, but what they refer to, because it's direct and indirect, which we'll get onto later, direct means that how do they change? They change together. That means when one goes up, the other one goes up, as opposed to when one goes up, the other goes down. So direct means they change together. They both rise together. They both fall together. They change in the same, and I guess this is kind of...
And also the inverse direction variation is just like the inverse way of this. So if one goes up, the other one goes down, and if one goes down, the other one goes up. So it's just like the inverse of this direct like linear variation. So yeah, so if you just like, yeah, an example, if you sleep like long time, then that means you will awake like less time. So one like increases and the other one decreases. So that's the inverse of this. I didn't get into that lesson yet, but yeah, but this one is just like they both like proportional to each other. So if one goes up, this one also gonna go up the exact same way, just like, you know,
of why you've got the word direct there. They change in the same direction, right? When one's increasing, the other one will increase. When one decreases, the other one will decrease. Linear. When we say one gets bigger and the other one gets bigger as well, we mean they get bigger or smaller at the same rate. And when you graph this idea of things happening at the same rate, you get a straight line. So if we put all of these three things together, direct linear variation is when you have quantities, they change both in the same way and at the same rate. That's what direct linear variation means. We can write equations that produce this. A direct linear variation equation, or variation equation for short, looks like something you're very, very familiar with, namely this. This is really simple. In fact, it's almost like a step backwards. We looked at more complicated equations than this with like a plus b hanging out here on the side. When you see a number in front of the x, you're used to seeing an m. You're used to seeing an m. What does that mean? that means the gradient. So it's like the steepness of the graph. Is it going up really fast or is it going up slowly? When in the context of variation, it gets a new fancy name. I'm just telling you it so that you recognize it in these questions. It's called the constant of, wait for it, proportionality. It just captures this idea that if something is in, or if two things are in direct linear variation, then they
Arkadaşlar.
are proportional to each other, right? You get some of these, they're in the same ratio every single time, okay? So, if this is the case, one of the ways that you can know that something is in, or two things are in direct linear variation is, if you have a look at these two values here, I can divide through by x, which gives me this. Bless you, okay? What this means is, when you divide a y by an x, you always get the same number. I say always the same because it is, after all, a constant, as opposed to these guys, which are variables, okay? So if you divide one quantity by the other one, bless you, you always get the same number. Let me show you what that looks like. You can open up, if you haven't already, to 9D. Let's do question 1 together, and you'll see how all these ideas are applied. It's cold. Should I get the heater in a second? I will in a minute. Okay, let's scroll down a little bit. Okay, let's begin. Right at the top, it says, complete this table which shows the price of packets of pencils. So before we begin, you can see what's happening here. The changing quantities are, have a look at them, how many packets you buy, and the price that you pay for those pencils. So these two quantities can change because you can buy more packets, you can spend more money, or less, okay? Let's draw up this table together, shall we? We're gonna need to have 6 columns, 2 rows. So let's draw it up. I'm going to abbreviate it just a little bit. I'm just going to put, rather than the full sentence, the full phrase, I'm going to put N on the top row and $P on the bottom row. Okay. By the way, while we're looking at a situation like this, one of these would usually be described as the independent variable, while the other one is the dependent variable. Which one do you think is the most natural choice for which one is which?
So, he didn't explain what these two variables stands for, but like one is the price, I think. One is the number of items that you are buying. I think he mentioned that. I don't know. So, the N is the independent, while the B is the dependent. Okay.
Yeah, I think probably the most natural way of thinking about it is the price depends on how many packets of pencils you buy. Okay, so usually we put the dependent one down here, and the independent
B stands for pencil. Okay.
one up here.
Well, he mentioned it also. I think.
So I'm just going to get this. They're vaccinating over there.
Seconds ago, but I couldn't make it sure.
We're going to just try out the values 1, 2, 3, 4, and 5. And you've got right in the middle here $4.50 as the price that corresponds to that number of pencils. Okay. So it says complete this table, which shows the price, with no other indication of any other change, like some group discount or something like that. We can assume that we've got direct linear variation here. You buy more packets of pencils, you're going to have to pay more money for them. So I'm going to use this equation down here. Dependent divided by independent. $4.50 divided by 3. $4.50 divided by 3. What's that equal to? Hi, what are you looking for? Sure, hold on. no one else here. Can you go to Mrs. Valentine's? Do you know where it is?
No.
Yep, I would assume so. I divided through. I got this number. What's the special name for this number in this scheme?
Constant.
Have a look. I've got it in red. It's the constant, because this thing's not going to change, right? Of proportionality. It's constant because the price of pencils is going to be the same every time. So I can use this guy to work out everything else. 2 packs of pencils at $1.50 each will be. Great. Oh, I don't need to put a dollar sign. I've already got one at the front. Over here, the single packet of pencils, $1.50, and I can keep on going. This is not complicated to complete. Okay.
Yes. Okay. That was so good.
Excuse me. That was part A, just to fill that out. Part B is just to graph it. So if I had to choose a scale, I'm going to have to go from 1 up to 5. So that's on the, which axis would that be? Horizontal or vertical? Choose a scale. I'm going to have to go from 1 up to 5. So that's on the, which axis would that be? Horizontal or vertical? Choose a scale. I'm going to have to go from 1 up to 5. So
Okay. So we wanna graph this. So which one will be the x and which one will be the y? So, okay. So x is the independent, right? So it should be then the vertical, while the the price of pencils will be the horizontal. I mean on the other way around, like the number of pencils should be like they are like independent, so they are the x, so it should be the horizontal, while the p, which is like, okay, the price of the pencil should be the vertical line. So n horizontal, p vertical.
So that's on the, which axis would that be? Horizontal or vertical?
He's talking about the n, so it will be the horizontal.
Horizontal because it's the independent variable, so let's do that. And I'm going to have to go up to 750, maybe 8 will be a nice round.
By the way, I'm answering the question as well. You should know I'm like literally grown ass man. I'm literally 21, but these are kids though. Like they are somewhere in elementary school, I believe.
Number to choose. Okay, so let's put those
Oh,
markings
that's so
in.
funny. That's so funny,
1,
man.
2, 3, 4, 5. 2, 4, 6. Okay, now, just like before, to get a straight line, you only really need 2 points. You don't have to put every single one on. If you've marked out all of your spots on here nicely, then if you've picked the 2 points accurately, then it will pass through all the other points as well if you connect them up. So on mine, I should find $1.50 is going to be 3/4 the way up here. That'll be $1.50 for a single pack of pencils. And $7.50 is going to be around there, so that corresponds to 5 packs. Excuse me. Now, with your ruler, if you've chosen these points correctly, I should be able to join them up, but I'm going to do more than just join them up. I'm actually going to go a little bit further down to the end here to include a point that I didn't have in my table. And it's actually a really important point, which is why I'm highlighting it. So when you join these up,
Should be linear, right?
number 1, you should be able to confirm if you draw your line up to where all of your other points should correspond to. For example, I went to 2. You should find that is equivalent to the other values that you got. You can confirm those really quickly. But secondly, have a look at where this graph begins. What is that spot? 0. It's 0, 0. It's the origin, right? Now this is really important because it's a feature of all direct linear variation situations. Every single one passes through the origin. Because if you've got none of one thing, if you didn't buy any pencils, then it's not going to cost you any money, or whatever kinds of two quantities you're comparing. Okay. Part C, we've actually already done this. The constant of variation is the same as the constant of proportionality. We've got it. It's, what did we say, $1.50? Write the linear equation for P in terms of M. Okay, so remember over here I said every variation equation will look like this, just with the appropriate choices of pronumeral. So which one's X and which one's Y? Every variation equation will look like this, just with the appropriate choices of pronumeral. So which one's X and which one's Y? Is this one going to be number of pencils, or is this one going to be number of pencils?
The X will be the number of vessels, and the Y will be the price.
Okay, X will be the number of pencils because X is what we usually label as the independent variable on which the other one depends. So where am I up to? Part D.
So the Y would always give you, like, based on what the input was, and the input was just like the X. So the output depends on the input, in other words.
The linear equation will look like this. If this is going to be N, it'll be $1.50 times N, which leaves P, the price, over on the left-hand side. There's my linear equation. Find the cost of 9 packs of pencils. Because I now have the equation, I don't need to rely on the graph. I can go straight to the equation and get it precisely. So I can say P equals, when N equals 9, $1.50 times 9. I think that's $13.
Can you do it?
$13.50. Someone tell me if I'm doing my numbers right. $13.50. Someone.
$13.50. This Asian dude, he can do it without calculator. This Asian dude, he can do it without calculator. Okay. It's $13.50. Okay.
9. I think that's $13.50. Someone
Yeah.
tell me if
It
I'm
is,
doing my
man.
numbers right.
Yeah, you're doing it right, man.
Before I write it down.
Because like you Asian, man. But math's your thing, you
There's
know?
the price.
I'm just
I
kidding.
should put some units
just
on there,
kidding.
so I'll put $P equals $13.50. And then lastly, if you see F, I'm going in reverse order. We've been tripped up by this before. I noticed in the AP4s we had a bit of trouble with this. You can have a formula. We give you so many formulas on the formula data sheet. The key is, do you know how to use them? If the price for N packs of pencils is $27, find N. So where am I going to put $27?
Over X here. No, I mean, okay, T.
$27 is a price, so I'm going to substitute it for where P belongs, so it's on the left-hand side, which is a little bit weird. So I'm going to get this, 27 equals $1.50 times N. One of the ways you can know that you've done this right is because you still have this pronumeral here, which is the one that you've been asked to find. Well, it had better be there, because I want to get a final line of N equals something or other. Now, I notice, just by coincidence, 27 is exactly double the number I got in the previous question. Yeah? I think that's just a coincidence. So therefore, how many pencils, without even using a calculator? There should be 18. And of course, you can double check that 27 divided by 1.5 gives you that number. Okay? Direct linear variation is pretty straightforward. The numbers are really easy, the values are easy, and the shapes are easy too if you were to graph them. Okay? So this is just sort of getting us warmed up for when we have direct nonlinear variation, and we have indirect variation, which we will come to in AM5. Okay?
So yeah, it was day 13 of studying multiple day. I studied 2 sessions. And yeah, it was great and amazing, to be honest. I didn't change this, to be honest. Oh my gosh, I literally forget that. But yeah, it is fine. Studied 2 sessions, so it is 2 out of 2. So yeah, it was another beautiful day, and I'm so glad that I got the opportunity again to study and to show up. So yeah, hope I will reach tomorrow well-being. So see you guys.